Good morning, YouTubers, and welcome once again to the mess hall at Dr. Jet Laboratories. I had a question from one of my viewers. First of all, I want to thank all my viewers. I don't make a penny off of this, and all I get is the satisfaction of sharing some information. And when somebody asks a perfectly good question, I'm more than happy to address it. Anyway, one of my viewers, who I will call Vladim, because that's his name, asked me why I'm offsetting the drive line in this hydro build. And I mentioned it's because of propwalk. And he asked, well, how does propwalk work? And I've seen offsets on riggers. Why are you doing it on the hydro? First, let's talk about propwalk. I have this bowl of water that I got from East Palestine, Ohio, and I'm going to demonstrate what happens. Now, all single screw boats suffer from propwalk to a greater or lesser degree, and a fully submerged prop at an angle has certain physical forces on it, and the apparent pitch of the upward blade is different than the apparent pitch of the lower blade because of the angle the water's moving this way. But we're not going to talk about that. We're going to talk about surface props and prop walk. And here's what happens with a surface prop. Get a load of this. As the propeller is spinning half in and half out of the water, the blade in the water wants to push the propeller. Not only does it want to move the water back, but it wants to push the propeller over to the side. See that? See how that would work? It goes in there and it just pushes it off to the side. Well, that's prop walk. So you've got this thing spinning, but it's the way it spins, it's only pushing one way. That's why counter-rotating props eliminate that problem. But anything with a propeller, airplanes have it. It's called P factor on airplanes, and you got to put in a lot of right rudder, and the motors are mounted crooked in the airplanes intentionally, with the exception of the Lancer, and that's a whole nother thing. But that's what's happening. Half of the propeller is in the water, and it's pushing the water to the side. Imagine, if you would, this had infinite pitch to where it was nothing but a paddle wheel. Then it would just move sideways. It wouldn't move forward at all. So that's what's happening. This prop has a forward force on it and actually a little force this way. So this prop wants to turn the boat. Well, let's see if I can do this without making a mess. Wants to turn the boat to the right. Well, that's cool when you're going around a corner, but when you're going in a straight line, you don't want that push to the right. So what you do is you offset just a little bit the drive shaft. Now imagine, if you would for a minute, I put the propeller out here. That would push the boat way to the left. And the idea is to have just enough offset to counteract that prop walk. And it works out to, in boats this size, about 1/4 of an inch. In my little 1/20th scale, I made it 2/10 of an inch. But that's kind of a general rule of thumb, even for hydroplanes. Take a look at the full-size hydroplanes. You'll see that the whole center cabin is offset. That's how they get around it. A good one was the Merlin Budweiser. God, when would that have been? That would have been the late 1970s, 78, 79, 80. Take a look at the Merlin Budweiser. It's offset a whole bunch. So there you go, Vladimir. That's why I'm doing the offset, is to counteract that prop walk. So the prop walk makes the back of the boat want to go this way. offsetting the prop makes it want to go that way. And hopefully, with everything, when all the stars are in alignment, it'll go in a straight line. So until next time, jet out.